In this lecture, we are going to see how to find the reactions of the simply supported beam when it is loaded with different kinds of loadings. So first we'll consider a simply supported beam with different kinds of loadings as shown there. And our beam is of length 6 meters and there are 3 different kinds of loads acting on the beam. We have a point load of 4 kilonewton acting vertically downwards and 2 kilonewton acting at an angle of 30 degree to the axis of the beam, and UDL of 3 kilonewton per meter is acting at the right end of the beam for 2.5 meters. Okay, great. Now, how we are going to solve this? How we are going to find the reactions of this beam? To know that, first we should know how many reactions the supports can actually provide. Since it is a simply supported beam, it has been supported with one simple support and one roller support. We know that simple support can provide 2 reactions and roller support can provide 1 reaction, right? Now we are going to use our equilibrium equations to find these reactions. Before that, let's resolve our inclined force into one vertical and one horizontal component. So this 2 kilonewton load will become 2 times sine 30 degree vertically downwards and 2 times cos 30 degree horizontally towards left. Now we will convert this UDL, uniformly distributed load, 3 kilonewton per meter into an equivalent point load, that is magnitude times its length. Its length is 2.5 meters and we will get 7.5 kilonewtons, and it will act at the CG of the UDL load, that is 1.25 meters from the point B. Okay, now we are good to solve the problem. First of all, assume the reactions AY, AX, which are vertical and horizontal reaction of the simple support. I am assuming them to be in the upward direction and towards right. Then assume BY, which is the reaction of the roller support. I am assuming that also to be in the upward direction. Here, don't worry about assuming the directions, because if you have assumed the direction wrongly, then our final answers will be in negative sign. So we can know the right direction after solving for the reactions. Since I have converted the inclined load and the UDL load into an equivalent load, so I have shown only the equivalent load in this diagram. With the assumed reactions, we will now start using our equilibrium equations to find our actual reactions. First, using summation of H equals to 0, which is summation of all the horizontal forces equals to 0. We will get AX minus 2 times cos theta, that is theta is 30 degree here, equals to 0. I am assuming the forces towards right as positive and forces towards left as negative. From this equation, we will directly get AX. AX will be equals to 1.732 kilonewtons. Here, see, as I said, the actual reaction came out to be a positive value, which means the direction we assumed for AX is correct. Now let's move on to the next equation to find our other 2 reactions. We will use summation of vertical forces equals to 0. That is summation of forces in the y direction equals to 0. Then what we will get, AY in the upward direction, we are assuming our upward direction to be positive and downward direction to be negative. So AY plus BY minus of 4 kilonewton, which is acting in the downward direction, minus of 2 times sine 30 degree, which is the vertical component of the inclined force, and minus of 7.5, which is an equivalent load, converted equivalent load for the UDL. That's it, equals to 0. Now simplifying this equation, we will get AY plus BY equals to 12.5. We'll keep this as our equation 1. After this, now we will use summation of M equal to 0 to derive another equation. Before using this equation, everyone should understand that this equation can be used only when you know the moment at a particular point. Only then you can consider summation of moments about that point equal to 0. But don't panic, it's extremely easy and most of you have already come up with an idea if you have watched my video on types of supports and types of beams. Okay, coming back, what is easy about this? It is easy because we know that neither simple support nor roller support can produce a moment. which means moment at point A and point B is 0. Correct? Yeah. We can consider either of the point, we will end up getting the same result. So suppose I am considering summation of moments about A equals to 0, because we know that the moment about A is 0, as I told. Then the equation will look like minus 4 times 1. Here we are considering clockwise moments as negative and counterclockwise moments as positive. As you can see, 4 kilonewton is acting downwards, so it is going to create a clockwise moment to the point A. And 1 is nothing but the perpendicular distance between the point A and the 4 kilonewton force. And the next is minus of 2 sine 30 degree times 2.5. And this is nothing but the vertical component of the inclined force, and 2.5 is its perpendicular distance. And the next one is minus of 7.5 times the 4.75 meters. That is the perpendicular distance between the converted point load from the UDL and the point A. Correct? Yeah. And what is the left out one? It is by times 6 meters, and it is going to create a counterclockwise moment, so we are using positive sign for that, and that is equal to 0. Now if anyone asks why I didn't use AX or 2 cos 30 degree in this equation, then I will have to request you to see my previous lecture on equilibrium equation. And coming back, solving this equation, we will get By equal to 7.021 kilonewtons. Now substitute this By in the equation 1 and get Ay, and that will be equal to 5.48 kilonewton. Here notice that both By and Ay are having positive values. Therefore, the assumed directions for By and Ay is also correct. Hence, we got all the reactions for the beam. We got Ax, Ay and By. That's the information I wanted to give you in this video. Hope you found some value in this video. If you did, make sure to drop a like. And if you're new to my channel, you can subscribe to it for more upcoming videos. Thank you and see you everybody soon in the next video.